Today I'll be going over question 4 from the week 4 worksheet. This question asks you to consider honey, which is a very interesting substance. The first part of the question asks you whether honey is an unsaturated, saturated, or supersaturated solution. An unsaturated solution is one where the solvent can take more solute into solution. A saturated solution is one where the solute dissolved and the solute in the precipitate that has come out of solution are in equilibrium. Essentially, the solvent can take no more solute into solution. A supersaturated solution is one where more than the equilibrium amount of solute has been dissolved. This is usually done by heating or the addition of some agent which stabilizes such a solution. Honey, being thick and viscous and full of way too much sugar, is a supersaturated solution. The next part of the question asks you to consider what would happen to an organism that tries to live in honey, say a bacteria, for example. Osmotic pressure is the important piece here. So let's consider osmotic pressure. Here we have the classic example of osmotic pressure. Here's the pressure difference, H, which relates to pressure in rho GH, which gives us pressure, which here is equal to the osmotic pressure, which is equal to mRTI, which is the molarity, the universal gas constant, the thermodynamic temperature, and the Van Hoff factor. So what is happening here conceptually? Well, the pure solvent is drawn to dilute the solution that has the solute that cannot cross the semi-permeable membrane. Solvent can cross, but the solute cannot. And that's what creates this pressure difference. In an organism, this will draw water out of a cell or push water into a cell. Here we have a red blood cell, for example, but this works just the same with a bacterium. In honey, we have a hypertonic solution. There is so much solute outside the cell that the water in the cell is drawn out. The cell shrivels up and dies, and thus bacteria does not infect your honey. Honey also has several other interesting properties, including a low pH and some enzymes which function antibacterially, which also prevent it from being infected by spores or bacteria or anything else that can hurt you. But you should remember to keep your honey covered, because such a solution will pull water in from the air, diluting it and getting rid of these properties.